some other folks too will be joining. So welcome everybody to this weekly Twitch on Java, cloud native, anything around like JVM and all that. So this time again, we have Vijay Sundaresan. Did I say your name correctly, Vijay?
That's right.
Thank you so much. Yes. So quick introduction is that I can't say it all, but it's definitely Vijay is, honored guest here. He's our senior technical staff member at IBM with the WebSphere runtime team. And you are also the Java JVM Runtimes Performance OpenJ9 expert and architect and leader. So really happy to have you here today, Vijay. Would you like to tell us a bit too about yourself so the audience will know more about you?
Yeah, sure. Thank you, Mary, for inviting me. It's actually a pleasure to be here with you all. So I'm Vijay Sundaresan. I graduated from McGill University back in 1999, so in the last millennium, I guess, or last century. And right at the end of 99, I joined IBM. When I first joined, I joined on the Java team as one of the early developers working on the just-in-time compiler. That's my background, actually. I did my grad school in compilation technology. And so I spent the first 10 or 12 years of my career, you could say, at IBM, being a pure JIT developer, leading teams within that team and writing one of the key components in the JIT compiler, which is the optimizer, very important for performance. So that was my first 12 years at IBM. And then after that, I took over as the Java Performance Architect. So my role broadened outside of just JIT compilation, and I started doing more general performance, GC, locking, everything related to OpenJ9 performance strategy. Basically, I tried to get involved in and drove the whole strategy. And then a few years ago, I think it's 4 years now, I took over Liberty and WAS performance as well as part of my responsibilities. So that's in addition to the Java Performance Architect role I was doing already. So that's my work history, if you will, at IBM.
Yeah, cool. Thank you so much. Obviously, you're very deep into like performance, JVM and Java. So that's why we're so excited to have you here. I have reached my limit on my kind of specific knowledge going so deep as you are. So so maybe you'll be sharing with us some of the techniques today, right? With cloud native, with Java, and also with our Semeru Runtimes just got announced. So you have much to share with us today. And so we are very eager to hear from you. But yeah, first, maybe just we'll chat a little bit too, right? So maybe just try to understand, right? What are some of the, say, the key factors? If somebody is going out, right, a Java project, we want to have pick a JVM. We have so many, quite a few choices now. And of course, OpenJ9 is the original J9 from IBM, and it's really robust. It's proven. It's a long time already in the making. So it's kind of a clean room in implementation too. So it's pretty impressive and ready for cloud and everything. But let's say, right, what would you advise folks to be looking for when we're picking a JVM? So,
yeah, it's a good question and also a very open-ended one. So I'll give you my view on it, and we'll see kind of if folks have questions or other comments. But really, picking a JVM is part of a larger question. I think it's picking a JDK really at its core. That's the bigger question. You pick a JDK, right? Like you go and download either Oracle JDK or OpenJDK or the IBM Semeru Runtime JDK. That's the most recent entrant into this market. But there's really your choice of JDK comes down to a few factors. One, sort of how you're using Java, like if you're using it for commercial purposes and have been using Oracle Java for a while. For the last few years, you've had to pay a licensing fee to get security fixes or to use it for commercial purposes. You have to pay if you want to continue using Oracle JDK. So those are some of the considerations that Java is no longer free for commercial use, basically. And so you have to you have to really think through where you want to go. So now let's say you went with one of the OpenJDK variants. There are lots of variants out there that are OpenJDK distributions. Different companies have their own. Amazon has one called Pareto. Microsoft has their own OpenJDK distribution. A company called Azul is very big in the Java space, and they have their own JDK. So really, it comes down to which version of OpenJDK you're interested in. You can't get all of these JDKs in all environments. For example, the Azul JDK is not available on all the platforms that the Semeru JDK is available on. So the Semeru JDK covers the standard platforms like Intel and ARM, AR64, but also is available on IBM systems, so like the Power Platform or IBM Z. So if you really want a single JDK distribution to be used across all of these different platforms, for example, like if you have different applications running on different platforms and you don't want a complicated JDK story, you can pick up one that sort of serves you across all your platforms. So there's platform considerations, as I said, there's licensing considerations, but there's also performance, and that's kind of my area. Obviously, the one difference about the Semeru JDK and it's unique in the market in that regard is that it's based on the OpenJ9 JVM. So that OpenJ9 JVM, it's part of an open source project. That's a source-only project called Eclipse OpenJ9. So you can search for Eclipse OpenJ9 and you'll get lots of hits, information about that JVM. And the Semeru JDKs are all based on the Eclipse OpenJ9 project. So why would you want to select Semeru? Largely comes down to why would you want to select OpenJ9 as a JVM? And for that question, I can probably share a slide that will make it easier. So let me do that. 1 second. Do you see my share, the slide?
Yes, I can see. So I think folks can see. Let me check the other screen. It's a little delayed. Yes, I think it's good. So. Okay,
great. So this is kind of the one-pager that we like to show when we're talking about why you should go with OpenJ9. So if you look, there's sort of all of the aspects of the slide are really worth paying attention to. The one at the very top, OpenJ9 has been used by IBM products for over a decade, really, for more like 15 years, I would say. It's embedded by a large number of IBM products as well as a large number of IBM customers. Lots of enterprise-grade software has been running on OpenJ9 for a long time, so it's proven itself in many different environments, many different requirements. So it's battle-hardened. It's got a world-class support team behind it, standing behind it. If you open a problem at the OpenJ9 project, it'll get looked at by the same team that has been supporting Java for IBM products for the last 15 years. So we know how to support our JVM. We know how to make OpenJ9 do what our customers want it to do, and we've done it for a long time now. The next thing that is mentioned at the top there is that one thing that people may not be aware of compared to all the other distributions or all the other JVMs, say Hotspot, which is the most common one out there, is that when we make changes to OpenJ9, whether they're performance improvements or bug fixes, those changes get out to all of our language release versions simultaneously. So we have a single stream that feeds into Java 8, into Java 11, into Java 16, which is the current latest and greatest, and soon there'll be Java 17, which will be a long-term supported release. All of these releases are driven from the same code stream. So when we release a performance improvement, even if you are on Java 8, you get your hands on it. Even if you're on Java 11, you get your hands on it. You don't have to upgrade to the newer version of the language. You don't have to get up to JDK 16 or JDK 17 just to get your hands on a JVM improvement. We are trying to meet you where you are, so all improvements are flowing out to all of these language versions simultaneously, as I said. So that's a key positive that I think is, again, makes Semeru and OpenJ9 unique in a sense, because if you go with the hotspot-based JDK, most of the changes that they release from a JVM perspective are only available in the later language versions. And of course, what you probably already know is that JDK 8 to anything later than JDK 8 language level is not a trivial migration, right? Like lots of things changed at the Java 9 or boundary, and going long-term support release Java 11 boundary. So your applications may need to be adapted to run with Java 9 or with Java 11, any of the later releases. And so we know of lots of customers who have not been able to upgrade past Java 8. So if they're stuck on Java 8, if you're stuck on Java 8 for a while because your application or something else that it depends on has not migrated above Java 8, cannot migrate above Java 8. The good news is with OpenJ9, you'll still get most of the performance gains that we're putting into the core JVM, because, as I said, it's a single stream that makes its way out to all of these language versions. So you asked Mary early on, why would we want to go with OpenJ9, or what is the defining characteristic here? This slide on the left shows sort of different performance metrics and how OpenJ9 does against hotspot. So in terms of memory footprint, we get 66% smaller footprint. If you run your application with OpenJ9, we have lots of testimonials. You can Google OpenJ9 memory usage or look at our performance page, Eclipse OpenJ9, the performance page, and it's lots of anecdotal evidence of people trying it and experiencing the smaller memory footprint. We can get much faster startup. And when we talk about this later, maybe in the context of cloud optimizations and so on, we can talk about why startup time is so important, but also what we have done to make the startup time, put the startup time into our customers' hands. So it's not just about having faster startup time. It's also about making it easier for our users to experience that faster startup time, right? To make the user experience relatively easy in order to get that improvement. And we get all this faster startup, smaller footprint, faster time to peak performance while maintaining comparable throughput to hotspot. So the 100% there says that we're not really slower from a throughput perspective, but while being comparable from a throughput perspective, we're able to give you all of those other advantages that are listed in that quadrant. And we can talk about, as I said, the broader context for why some of these things matter in the cloud when we get to that point. I'll end this slide, talking about this slide with the bottom part of it, showing all the platforms that OpenJ9 is available on. So if you're interested in those platforms, you can just download it via Semeru if you wanted and try it out and experience these advantages for yourself. Did that help answer the question?
Yes. Yes. Yeah. That is very good. Yeah. Very detailed. Thank you. Thank you. That was very good. So, yeah. So let's see. Then because then you brought up, right, the OpenJ9 having such a smaller footprint and everything, more efficient, is really like fitting in today's cloud native kind of environment. So what are the changes, though, have you seen, right, in the OpenJ9 in order to adapt to this cloud native, cloud computing world that we are living in? Yeah, what kind of things have been introduced to it, right? From that you find that's interesting that you can share with us that really make it superior.
Yeah, so this is a multi-part question. I'll go back in history to try to answer this as well. So some of the things that we did in OpenJ9 to benefit the cloud world and cloud native applications were done even before we really knew what would benefit or what cloud native applications look like and what would benefit them. I guess the core principle we've had for the last 15 years or even 20, close to 20 years really is that a balanced approach to performance. So by that, I mean, we want to look at footprint, we want to look at startup time, we want to look at ramp up time, we want to look at throughput. We want to look at all of these things, but we've been doing that for 20 years. We didn't start doing it in the last 5 years when cloud, or last 10 years when cloud and containers have become much more popular. So in a sense, OpenJ9 was ready for cloud when the cloud trend even arrived to begin with, because we've had that balanced approach to performance from the beginning. So that led to a pretty good memory footprint story, a pretty good startup time story, I mean, basically throughout the last decade. And why do these things matter? So when you're on the cloud, you're oftentimes paying for resources, especially in the public cloud. There are many applications and many services that charge by gigabyte hour or gigabyte second. So in other words, memory footprint matters and can affect your bottom line quite substantially. If you're able to run the same application with lesser memory footprint than some other JVM can, then that's great. That means you can size your container smaller. You can buy smaller VMs when you're on a public cloud, and just it translates to lesser cost. The faster startup time that we've had and built up over the last 20 years, that matters because if you're in a cloud environment, and as I said, you're paying for stuff in a cloud environment fundamentally. You're paying for instances. So you don't want to keep instances up and running if you're not going to be using them. But if and when there is an uptick in customer load, in sort of customer activity, you may have to bring up your service really quickly to deal with that demand, right? That surge in demand. And so you need the ability to start up new servers, new instances, new containers as quickly as possible and be responsive to customers making requests on your website, for example. And that's where the faster startup time comes in. You can bring up a server more quickly. You can have it reach peak capacity more quickly with OpenJ9. So that's the broader context in a cloud setting. Now, some of the things that we've done specifically since containers and cloud became so important, we've gone and specifically built in container awareness into the JVM. Now, what does that mean? If you're running your Java application inside a container, and the container is running obviously on a physical sort of host or a node, and that physical node has let's say a lot of memory, it has a lot of CPUs, but those resources aren't allocated to your container. A single container might only be limited to one CPU and may only have a fraction of the overall memory that is there on the underlying node. So what we need to do is really to recognize the memory that is available and the CPU that is available for the container, not for the whole host, not for the whole node, but for the container, and reflect that back into the application. Also make sure the JVM itself takes that view of what is available to it rather than the whole server or the whole node. Otherwise, things can be dramatically out of whack. Like if you think you have 64 CPUs, but you only have one, you can imagine how the application may behave oddly. It may make wrong decisions. The JVM itself may make wrong decisions. It may decide to employ tens of GC threads, and now that's not optimal because you only have a single CPU, and you can waste a lot of time that way and waste a lot of footprint that way as well. So the first thing that we did was really to recognize what is available to the container and reflect that up both to the application as well as to the internals of the JVM. So we only respect, or we respect what is given to the container. The second thing that we did was really to start adapting some of our long-standing technologies to work better in a containerized world. So, for example, this faster startup time is achieved using a particular technology. I won't go into details of that technology. It's called shared class cache. That's what is at the heart of this faster startup time, 42% faster startup time that you see with OpenJ9. Now, how does the shared class cache work in a container world? There are fundamental inconsistencies in how containers work versus how the cache was working. So what we did was we adapted this long-standing technology that we had around shared class cache, adapted it to the container world. We made it aware of notions that are there in containers, like layers. You can build container layers one on top of another. You can build container images one on top of another. And similarly, you can put a shared class cache layer at each one of those layers in the container image. So we modernized essentially this powerful technology that we had and made it work better in a container world. This allows our users to build their own shared class cache at their own layer without worrying about layers above them or below them, for that matter. They can just right size the cache that they want for their layer, for their application, and forget about everything else. So this is the sort of modernization, if you will, of existing powerful technology that was there in OpenJ9 that really brought some of these advantages to users of containers, made it easier for people building their container images to use. And then the final bit, I would say, are some of our more ambitious plays. So there's at least a couple of different areas where we're really pushing the boundaries. Your question was around has the JVM evolved for cloud native applications? Well, one of the major innovations we're doing or exploring at this point is really how to make the JVM itself more cloud native. So rather than have the JVM sort of be one monolith with all the different components inside that JVM, so the garbage collector, the JIT compiler, all are part of this one JVM that is inside each container. What we're exploring is this feature called Jit Server, which separates out the JIT compiler from the rest of the JVM. And so it allows you to create essentially a JIT compiler service and separate that out. And you have clients connecting to the service, asking for JIT compiled code. The service does JIT compilations and produces code and gives back to the clients. And what this allows you to do is to scale the JIT compiler up or down independently of the rest of the JVM. So if demand is high, you can scale up the compiler. Demand is low, you can scale it down. It allows you to separate out concerns. You don't have to bloat every single client that wants to do JIT compilation. Clients are separate. Servers, the JIT server is separate, and they just exchange messages across the network. So it's kind of becoming more cloud native in a sense, the JVM itself becoming more cloud native in a sense, and having those same advantages of being able to scale individual parts of your JVM separately, kind of the same thing that you have with microservices or a general sort of containerized world, a more cloud native world where you're able to scale up or down individual parts of the overall application. Yeah. There's another very cool project called JVM Snapshot that we're exploring in the last few months, 4 months or so. But before I go there, I'll pause and see if there are questions or comments on what I've been saying for the last few minutes.
Sure. Yeah. So I think it's great what you have shared, but I'm kind of monitoring that comments section. Nobody asked questions except a couple comments. I think one from Fullsnabel. I hope I say your name correctly, but he was just saying that he or she is saying that OpenJDK means I can keep Oracle lawyers further away, which sounds good to me. So that's it. That's a fun little kind of comment.
Yes.
So thank you. That's good. Yeah. So I
Yeah.
hope the audience too, you are trying out using our OpenJ9 runtime. I'm hoping so. And also we have Dragon Lord Blake saying that I guess he likes the our Duke that I put on top on the screen here. So just thought I'd kind of make this more Java friendly for this particular session. So yeah. And does anybody have any questions for Vijay in particular about JVM runtime, Java? I think anything related to performance, especially we have an expert in-house today. So so yeah.
One of the things I remember, Mary, you saying was that you get some folks from the gaming community and so on. So one thing I thought I'd mention is if you Googled OpenJ9 and Minecraft, you're going to get quite a few hits because OpenJ9, the JVM, is very popular amongst Minecraft community because of its memory benefits. And that's actually one. I mean, it's not a testimonial listed on our performance page, I think. I think we have other enterprise testimonials listed there, but I just thought I'd mention that because if you are in that sort of gaming sphere, maybe that's something interesting to you and maybe catches your fancy and you want to go and try it, which is ultimately what I'm saying at a high level, right? Like you should be going and giving this a shot and see what it does.
That is a very good point. Yes. Yeah. In fact, I think gaming industry, they're all about the fast turnaround, the performance, the efficiency, everything with that. So that's great to know about Minecraft. Yeah, now I kind of will look up some more, look up some resources and share with our viewers too. So yeah. So does anybody have any questions? And it's a little bit quiet today. So some days I got a lot of folks talking, but today maybe not everybody's online yet. But we also get folks watching us, I guess, in the after viewing as well. So yeah, but I guess if folks wants to ask you more questions, right? Maybe let me kind of ask you, Vijay. Of course, they can go through me, and then I can present the questions to you. But let's say, Vijay, do you have your Twitter or maybe LinkedIn? Folks can connect with you there if they're really interested, going deeper into the performance aspect of things.
Yeah, definitely. You can find me on LinkedIn easily, and I'd be happy to help send any questions you have, even if it's not something I can directly fix in the JVM. I'd be happy to sort of give you my view, even if it's sharing a view about something like Java performance in general, or new features in the Java language, or in fact, there are some new features that are coming up too that are interesting that we could talk about if we had the time today. But I'll pause again and see if anyone wants to ask a question or comment on what we've said so far.
Yeah, I think we have Fullsnabel asking any known issues going from Java 8 to Java 9 that I guess that you're aware of.
Yes, in fact, Java 9 introduced this big feature called modularity. And what that means is that it puts stricter limits on what you can do or a certain piece of your application can do vis-a-vis other pieces of your application. So in the past, you've had a notion of classes, packages, in Java, and you have rules around which class is allowed to see which other class, which method can be called from another class, etc. So these are called visibility rules or access rules. And with Java 9, you had the notion added of modules, and modules basically, in a sense, made some of these rules more strict. So if you're in different modules, unless someone exports a particular API, you're not allowed to call it. So the back doors are closed. So for example, you had applications that were indirectly accessing methods in the Java class libraries themselves. Applications that should not have been able to call these APIs that were considered internal to the Java class libraries. I'll give you one example of such an API. It's an API called sun-misc-unsafe, which is a very powerful API. It allows you to basically access any memory that you want without checking the usual checking that Java enforces. As you can see, there's a when I say it like that, when you're not checking the memory in the same way as you would if you're using unsafe, you can see how that's not fit for general use, right? Like you don't want application developers using that API and shooting themselves in the foot and sort of moving away from the very value prop of Java, which is that it's safe and checked, and you don't get crashes ever, you only get exceptions, and so on. These are guarantees, nice guarantees that Java has, and you don't want to spoil it all by using this unsafe API. Anyway, but that didn't prevent applications from finding a way to access this API, sun-misc-unsafe, and calling it and using it in their own applications over the last 15, 20 years. But what happens with modularity is that all of that code that's in the core JCL in the Java class libraries is in its own module. And so you're not allowed to call that code unless it gets exported. So you're forced to basically change your application to no longer do these kinds of backdoor things and really make sure you're much more proper, if you will, and adhering to the rules in order to move up to Java 9. Now, there are examples, or there are command line options you can use to continue having your application work with Java 9 or Java 11 as well. Basically, you can cheat and tell the JVM, yeah, I know that the rules have gotten stricter, but please don't enforce the strict rules for me. Like I want to opt out of the stricter rules. And so you can specify an option on the command line that opts out of that. But again, like this is not ideal, and most applications don't really want to be supporting Java 9 or Java 11 in this way, right? Like if you're an open source project, you don't want to announce support for Java 11 by saying, please use a backdoor or please use this command line switch to basically disable all these safety checks in Java 9. So in order to properly support the new version of Java, you need to change your application to make sure it's not doing any of those backdoor things that Java 9 wanted to avoid. So really, that's a barrier for applications to migrate up from Java 8 to newer releases. That's not to say that it hasn't been done. I mean, Java 9 and Java 11, in fact, has been around for several years, 3 years almost, Java 11, and even longer, probably close to 4 years for Java 9. So it's certainly many packages, many frameworks, many projects have adapted their code to work with Java 9, but there are also many projects which have not. So at this point, if you asked me what I know of the OpenJ9 user base, I would say about 50-50 almost. 50% are still on Java 8, and 50% have moved up. So there are genuine barriers here. There are genuine issues here, and so in the long term, I think you should be looking at moving up to the new versions of Java and adapting your application, because you can't be, you probably don't want to be stuck on Java 8 forever or for a very long time.
That's right. Exactly. That's right. Then talking about which two, so when can we expect, right, the OpenJ9 to be ready when, or the Semeru, I should say, right, with the JDK Java 17? Would that be, we can expect it to be ready within a month or so, something like that, or?
Yes. So that's a good question, Mary. Semeru is obviously a separate sort of JDK distribution to the main OpenJDK distribution. with Semeru, with OpenJ9, one of the things that we try to do is stay basically in lockstep with where the OpenJDK community is. So we don't have a guarantee that we will ship the same day or anything like that, but we try to ship very, very close to the date that OpenJDK ships a new version of Java or a new language version like JDK 17. So that would be our goal for JDK 17 as well. Sometime within, I don't know, a few days, max a week or two, probably after the OpenJDK release happens, you will get Semeru builds of JDK 17 happening as well.
Oh, that's
At least that's our goal.
Oh,
I mean, I'm no release engineer, and I don't want to get into trouble with those folks. But
sure.
but that's our aspiration, is to stay lockstep with the OpenJDK community. If you're a user of OpenJ9, if you're a user of Semeru, we don't want you to be falling behind. Like, we want to put all the latest and greatest language features into your hands and give you a first-class experience. Yeah.
That's right. Yeah, that's cool. Thank you. Let me kind of go through this comment section again. I think Full Snubble, after he asked about the Java 8 to Java 9, he also has, let me kind of show it. So he's saying we were using hotspots and then Oracle changed the licensing and then we switched to OpenJDK, which was painful. Okay, we understand that. So use OpenJ9. So yeah, okay. And then he also has another question. If you 1,000 plus repos and lots places, you reference the hotspot JDK implicitly and explicitly. Is that a question? Oh, it's just, I think, a comment. He's saying it takes time. So yeah, totally.
Yeah.
Okay, and then he also has another comment that he'll be migrating at least by 2030. Okay, that's cool. Very good. Yeah.
Yeah, that's true, because of all these problems with migrating applications up from Java 8. Various vendors have stepped up and announced support schedules for Java 8 that are quite long. So in certain cases, you have support available all the way up to 2030 in some cases, as I said. So you do have time, but on the other hand, it's always better to, I mean, Java 8's been out now for almost 7 years. So it's really already a long time, I would say, to be stuck on Java 8. And the longer it goes on, the more sort of you're missing out on not only language features, but also potentially sort of things that could exploit the newer hardware features and so on, because things are being added to the Java language. I'll give you an example of a feature that's coming up, a forward-looking feature that's coming up around vector exploitation. So there's a new API called the Vector API that is going to be added to the Java language. And this Vector API basically allows you to access SIMD hardware on the machine, so specialized hardware that can operate in parallel. So you can do 4 adds in parallel or 8 subtracts in parallel, depending on the parallelism available on the chip that you're running on. So if you're stuck on Java 8, you lose the ability to exploit the Vector API, which in turn deprives you of the ability to exploit the hardware, the specialized hardware on the machine you're running on in a direct way from Java. So there are all kinds of interesting features that are being added all the time. So as you know, Java releases on a 6-month cadence now. Really, you could be missing out on a fair bit if you're stuck on the older versions for too long.
That's right.
So it's always a good idea to plan to move up, really.
Yeah, that's right. Cool. And I think now we actually also get a question from, let me show it now. Narman, Narman saying, for a project using Java 11, which key requirements should be considered before moving to OpenJ9? Also, how time-consuming could migration be for a team with bare exposure to OpenJ9?
Yeah, so from an OpenJ9 perspective, there really shouldn't be too much hassle at all. Like Java is a very well specified language. So there's a detailed Java language specification. There's a book on it, and there's a separate whole separate book on the Java virtual machine specification. And Hotspot implements what's in the Java virtual machine specification, so does OpenJ9. So because it's a well-specified standard, so it's sort of, there are relatively few surprises, unlike some other languages which have a reference implementation, and basically the behavior of the language is dictated by the reference implementation. Unlike that, Java has a pretty good standard, I would say, a pretty good specification. And so as long as you implement that specification completely as OpenJ9 does, there aren't really any differences that you should expect. As I said, there's tons of customers using OpenJ9 in production for 15 years. We've had tons of people use OpenJ9-based OpenJDK builds over the last 4 years while we've been open source, folks out in the community. And I mean, sure, there could be the odd bug that gets found out, but if you open an issue with the project, it gets dealt with at a relatively high priority, especially if it comes from an external user. The other thing I will say is that 9 out of 10 times, or 95 out of 100 times, you don't even experience any issues whatsoever. So we don't even hear from a majority of customers who do the migration. It's almost a bigger question mark around migrating from Oracle JDK to OpenJDK, where there are some subtle differences that you have to look at, but that you may have to do anyway if you want to get out from the licensing issues, or don't want to pay the licensing fee directly to Oracle. You may have to deal with that migration itself. But switching the JVM, or moving from a hotspot-based OpenJDK to an OpenJ9-based OpenJDK, as I said, 95 times out of 100 or 99 times out of 100 really is a non-issue, and you pretty much just get those improvements that I talked about out of the box. The footprint improvement definitely is out of the box. The startup time improvement, a little bit of it is available out of the box. More of it you can tune and get more of it as well. So that ultimately may be the biggest difference, is that if you know of tuning knobs that were specific to Hotspot, you may have to, or were using such tuning knobs, you may have to retune for OpenJ9 because it's a completely different JVM implementation. But to counteract that, you have several improvements that are just available out of the box. So you may just not even have to tune as much. In fact, that's an effort we've made over the years to try and keep our defaults relatively sensible, so that you don't have to spend time, your engineers don't have to spend time tuning 20 different parameters in the JVM. We try to get things, provide as balanced, as I've said before in this call as well, as balanced a view as we can out of the box, choose sensible defaults, and hope that the user gets what they're looking for without having to really fight too hard with the JVM.
That's great. That's awesome. Yeah, that's good. I know you also have some presentation, but would you like to still answer a couple more questions first?
Yeah, I think we should. I mean, the presentation was just like a backup to sort of show certain things when the need was, but for sure, let's go with the questions.
Okay, now I have another one on the screen. Full Stable asks, are there any Java compilers that compile to WASM, by the way? So the WebAssembly.
No is the short answer, at least as far as I know. I mean, the Java compilers take Java bytecodes and produce assembly code or binary code for the most part. So they're not. I don't know of any Java compilers that take in Java bytecodes and produce WASM. Now there are other, or there's an offshoot of the OpenJ9 project I won't even call it an offshoot. It's really, there's two open source projects. There's an Eclipse OpenJ9, which we've been talking about here. And there's another open source project called Eclipse OMR. And Eclipse OMR is kind of the underlying underlying runtime componentry that OpenJ9 uses to build a Java virtual machine. So the difference between Eclipse OMR and Eclipse OpenJ9 are OMR basically has language agnostic components. So it'll have compiler componentry, but not tailored to Java. It's kind of general compiler stuff. You'll have garbage collection code in OMR, but not tailored to Java garbage collection. It's tailored to doing garbage collection in general in any language, and so on and so forth. Like OMR is a very nice project with lots of rich componentry in there. Now, why I bring up OMR here is that we have had some explorations done. We've had some research projects that have used Eclipse OMR to sort of be a code generator for WebAssembly, and you create like a WebAssembly runtime that hooks up with whatever the main WebAssembly runtimes are out there, WASM, Wabbit. These are some runtimes that I know of that run WebAssembly, and to use the same optimizations, the advanced techniques that we have that are used in OpenJ9 for WebAssembly as well. So to take in WebAssembly and produce optimized code out, that sort of flow we have explored in the past, but we have not explored going from Java bytecodes to WASM itself. Yeah.
Cool. Thank you. Yeah, that's interesting. Yeah. Okay, so Fu Snapball also has another question. Any GC changes in OpenJ9?
Yeah, mostly good, I would say. So OpenJ9 GC is actually way simpler to tune, as well as just the out-of-the-box behavior, in my opinion, is way simpler. And one evidence of this is just the sheer number of articles that you will find online on how to tune the hotspot GC. It's quite complicated. It's got lots of knobs, and my understanding is it's not trivial to get right. Let's just put it that way. That there are several folks who've made almost a specialty out of tuning the hotspot GC to achieve what they need. Whereas with OpenJ9, things are, again, this emphasis on balance and this emphasis on out of the box comes to the rescue a bit. Our default GC policy is called GenCon, which we believe is suitable for most workloads. We've done a lot of work on it over the last 2 decades. Again, like, I'll just invent a rule of thumb that 8 out of 10 times you're probably good enough going with that default GenCon GC. You may have to tune the heap size, like in particular the overall heap size, but that's simple. Like you're probably expecting to do that anyway, -XMX, and you may have to tune the nursery size. So GenCon has this notion of new space and old space, and so you may want to figure out what the nursery size is that's ideal for your application through explicit tuning. However, even there, we continue to do work to improve our out-of-the-box experience and provide heuristics internally that will just choose the right nursery size and behave well out of the box. So that's one thing I would say. It's simpler, easier. Those are phrases I'll leave you with regards to OpenJ9's GC. But the other thing that I will say is, if you want a specialized behavior, for example, if you have really large heaps, if you're worried about worst case pause times, there are other GC policies that we have. In particular, there's a policy called balanced, which we think is the balanced GC policy is kind of suitable for certain kinds of scenarios, large heaps, low worst case pause time. And it's also the vehicle for a lot of GC innovation that we're doing going forward. So we're trying to improve GenCon, our default, but almost as much effort as that we're putting into balanced GC as well, with an effort to improving it and making it more suitable as well for more and more customers. So those are the two that I would point out, but there's a whole page devoted, quite a detailed page I would devote it to all the different GC policies that OpenJ9 has. If you search for OpenJ9 GC, you'll get a lot of detail, including about GenCon and balance that I talked about here.
Yeah, I have it actually open in here. Let me kind of quickly point out, I create a banner and show it to folks in here. And yep, this is the one. Yeah, so yeah, I actually have it open in one of my tabs. Somebody was accusing me of having too many tabs, but then I was like searching for the tabs that are useful, and this is actually what I've opened. So yeah, in fact, now that we talk about GC, and I don't see another question right now, but I'm actually curious too, Vijay. So I understand too, Oracle, they are, or the the Oracle team, they are now, the GC team is coming up with the ZGC, the concurrency supported, right, GC. So would there be any of such feature then in the OpenJ9 to handle like concurrency type of GC?
Yeah, that's a good question. So there's really two answers to this. So there's a question. So the short-term answer that you can try out now actually is to try out this GC policy called concurrent scavenge. So that's a policy that was created in the last couple of years, really to reduce our average pause times, or our pause times related to new space collection, what we call scavenging. So that's why the name concurrent scavenge. So we've introduced this technology that means that you have far shorter pause times, GC pause times on average, because scavenges are much more frequent than global GCs. So your average is dictated quite often by scavenge pause times. And so because we've improved scavenge pause times quite dramatically, actually, if you use concurrent scavenge, I think you get an order of magnitude, if not 2 orders of magnitude improvement in your scavenge times. So really quite powerful. In some cases, you may be able to tune your application such that you don't even do global GCs, that all you're doing is scavenges all the time, in which case concurrent scavenge is really fantastic for you, because it achieves that order of magnitude improvement for all your GC cycles, essentially. Now, what concurrent scavenge doesn't do is address the global GC pause time, because it's only technology geared towards scavenges. So if you have one global GC out of 100 scavenges, that one global GC is still going to take time and is going to pause your application. So the way we're planning to address that is, just like ZGC is being built, we plan to build similar technology using our balanced GC based technology that I mentioned earlier. Balanced GC is a region-based technology, as is ZGC. So it's not based on just a notion of new space and old space. It's based on a notion of regions that different regions that are collected concurrently, and really the ages of those regions can vary across a broader spectrum, rather than just classified into 2 buckets, new and old space. So short answer, we do intend to explore a solution like ZGC for worst case pause time using our balanced GC technology. But in the meantime, you should be able to use concurrent scavenge and see drastically better average GC pause times already. And that technology has been available for a few years now, also available in Java 8 and across all platforms. In fact, on the Z platform, it uses the underlying hardware as well to achieve even better results. So it's got integration with it's got special hardware that was added to benefit this concurrent scavenge GC policy. And so the JVM quietly, transparently takes advantage of that hardware as well.
Oh, okay. Well, that's good to know about the Z system having that. Yeah, cool. Thank you. Yeah, awesome. And then let's see. I'm kind of scanning through. I think Fusnabo has another question here. What about NOP GC? I think, or did you already address that too?
I assume this is just the no GC or avoid GC altogether. Probably is what's. Did you say NOP GC?
Is that right? Fusnabo? Can you? Yeah. Yeah. Let's see. He didn't say. Fusnabo, do you want to explain? Do you want to get on the screen? You can too. I can send you. Oh, okay. Let's see. He was just saying that. Oh, okay. So he's just saying that what I meant was a GC that doesn't do anything.
Yeah. Yeah. So that's fine. I think we do support that policy as well, but it's not really a policy that is great in my personal opinion, because one of the advantages of Java is that it is going to provide that automatic memory management for you. And if you're not using any GC, which you might want to in certain circumstances, but you have to be very careful that not only you don't allocate objects at a significant rate, but nothing that you call does so either. And most complex pieces of software, or even moderately complex pieces of software, are built on libraries, right? Like you call some other API or some other library which provides you a significant function that you're interested in. So to be able to come up with a guarantee like that neither will I allocate much, nor will anything that I call allocate much, really quite quite a big burden, I feel, and one that Java programmers in general haven't had to deal with and shouldn't have to deal with to some degree, especially 25 years after Java's come into existence. So unless you know what you're doing and are very clear about it, it's not a policy that we generally talk about much or recommend in an enterprise scenario, because most large pieces of software, most of our customers, let's say they're using OpenLiberty or WebSphere or Spark or Hadoop or one of these big sort of packages, popular frameworks out there. It's a given that you're going to be allocating objects. It's a given that you're going to be calling libraries that are doing that, and so you rarely have that degree of control.
Yep. Cool. Yeah. So did that answer your question, Fusnabo? So let's see. Looks like, yeah, he has a few comments in there. So if you want to read through too, but otherwise, I don't see any more questions in here. And I know, Vijay, you can only be here only up to a certain time today.
Yeah, I have to drop in a few more minutes, but okay. If you had other things to ask or bring up, by all means.
Yeah, that's right. Yeah. Does anybody have any more questions? Yeah, I guess maybe not. Yeah, I'm not seeing anybody asking any more questions. So, yeah. Okay, I think maybe Fusnabo's the last comment he made was, "It's just good that the option exists for the specialists." So,
that's right.
That is
yes. I mean, one of the things I'll end on a humorous note is that one of the sayings we have on the performance team is one can never make a statement like, well, I know that this particular feature won't be used in this particular way. We cannot make that sort of comment because the world of Java applications and users is so big that there's someone somewhere who's doing something that you don't really expect or never anticipated. So the option being there in this case is good for those people who really are in a piece of code that they control in their entirety and really do not want any sort of interference. But yeah, I mean, for a large majority of customers, it's like this is one of the biggest advantages of Java, right? That it is automatically garbage collected.
Exactly. Yeah, totally. So yeah, very cool. Very cool. Yeah. So does anybody have any more questions? Yeah, I guess then otherwise, maybe we can reserve another time for you, Vijay, to come back and do a presentation on the other, you were going to talk about something on more techniques, right? And I think that
Yes,
would be
for
interesting
sure.
too. Maybe we can have you back then at another
Definitely.
episode.
That
Yeah.
would be great.
Yeah.
It was fun interacting with all of you, and thanks
Thank
again,
you.
Mary, and
Thank you.
everyone for attending. And thanks, Mary, for the opportunity. I appreciate it.
Thank you. Thank you. Yeah.